Hey everybody. So today we're going to start talking about vectors, and we'll do two sections from chapter 6, 6.1 and 6.2. So today is the first of 3 days in chapter 6. And so getting us started, we're going to be dealing with vectors in a plane, okay? So what are vectors? How do they apply? How do we use them? And so forth. And so with that, let's go ahead and we'll be looking at two-dimensional vectors specifically, and then vector operations and unit vectors today. And so we will end up doing our directional angles and some applications tomorrow out of 6.1. So using directed line segments, we will go in, and the idea behind directed line segments is that we start off with a point, and the way we get to the point is going to be our vector. And so while a point is notated with parentheses, a vector that leads to that point would be notated with angled brackets, and it goes from the origin all the way up to that original point that we had. So let's go and look at some definitions and some terminology for us. So two-dimensional vector is an ordered pair of real numbers denoted in component form, which is what our angled brackets are. The numbers A and B are the components of this vector. We tend to use letters like V and U to represent vectors, but they're just another variable standing for, hey, this is a vector. So the standard representation is going to be in that angled format, and at the end of our lesson we'll get another notation for vectors as well. And you'll have to be familiar with both because the ACT does switch between both notations. So with the arrow, when the arrow is pointed from the origin to the point, the magnitude, and we'll get a formula for that in a minute, is going to be the length of the arrow and how long is that arrow. And then the direction is which way the arrow is going to be pointing. And so the vector, the zero vector specifically, noticed that notation-wise, this one is bolded and in zero, because when we name the vectors, they do get bolded. I know that's kind of hard to show in your notes. And so with them, when we have the zero vector, it means both components are zero, and so it has zero length because it doesn't go anywhere. It also has no direction. And so its magnitude is zero because the magnitude is the length. So let's keep going. And looking, initial point minus terminal point. The initial point is going to be where it starts, and its final point, its terminal point, is where it ends, okay? So we will end up finding a way to how do we write these out, and then we'll also end up going through and talking about, okay, well, this one, both of these are our initial points. My handwriting gets worse on tablets. And so both S and P are terminal points in this case. So for head minus tail, that's going to be how we can end up writing out our vectors. And so how do we write them if I'm just given 2 points and I don't start at the origin? Because that makes it a little bit harder. So specifically in that last example, we had one that didn't end up starting at the origin. And so you end up needing to identify, okay, where do I start and where do I end? This is really important because otherwise you'll end up with your arrow facing in the wrong direction. And so this one looks a lot like our distance formula in one dimension, but now we have it for both, okay? Oh, And so we'll use it. So x's, I'll subtract the final minus initial and the final minus initial for the y's as well. Okay, so let's actually go back and look at these two over here. So for my vector, OP, because we'll start at the initial when we label it, this vector would be written as 3 minus 0, and we're going to start all over. So my vector would be 3 minus 0, and then 4 minus 0, because I'm subtracting my final minus initial. So the vector OP is actually the vector 3, 4. So on the same note, the vector RS, so I write it with my initial value first and my terminal point last. This vector will actually be written out as 6 minus negative 4. Nope. I combined it x and y's. So be careful, because it's going to end up happening. One thing that will help you prevent making the mistakes I've made a couple times here is to go in and label them. So this is my x1, y1, and this is my x2, y2. So I would have negative 1 minus negative 4. And I'll also have 6 minus 2. So to simplify that out, because I want it in component form, which means I want one value in the x and one value in the y. So going in, we'll have to change that negative to a positive. And so I would have 3, and then 6 minus 2 is 4. And so that would close off my vector. Now, notice that this one does bring up equivalent. So equivalent vectors are vectors that have the exact same value. They're just located in different places. And so notice that the length of both of these vectors, and you'll see that when we get our magnitude formula in a minute, is the exact same thing. And so due to the fact that the length is the same and they're both pointing in the same direction, they end up being equivalent vectors. So let's go ahead and go look now at our magnitude. Okay, so the magnitude, if you use it, we have two different formulas that were provided. Okay, so the first one is point form. And the second one is in vector form. Honestly, I think it's always easier to change it into a vector and then use vector form. But so let's talk about these formulas right quick, and then it'll make it a little bit easier to use. So notice that the magnitude is actually just our distance formula. And so between 2 points. Because of that, that's going to end up giving me a nice little value. And then if you think about using our components, so if I draw a vector whose components are A and B, think about all the triangles we just finished, which I know we're kind of stoked that trig is mostly done. My A component of my vector is here, and my B value is here. So I'm looking for the magnitude of my vector V. I can use my Pythagorean theorem. And so that is where that formula comes from up here. It's using our Pythagorean theorem. You can use it in both formats. You have to know the vector form, because if I give you the vector, you're going to have to jump right into your magnitude. And yes, the magnitude notation does look like it's just absolute values. So with that, whichever format equation you're using, make sure that you're holding on to your pieces. So let's go and find the magnitude of our vector PQ. And PowerPoint did, sorry guys. PowerPoint, for whatever reason, is not including the arrows on our vectors. Okay, so for our vector PQ, first it says it wants to find the magnitude of the vector represented. So we can do it in two different ways. So let's practice it with using both formulas just because it'll give us the practice. So first of all, let's do it from point form. So using that point formula, we're going to go ahead and go in here. And so because I have been messing up my x's and y's earlier today, my x1, y1, x2, y2. Okay, so to go ahead and use our formula, I'm going to put the absolute values around my vector to say, hey, look, I'm taking its magnitude, I'm finding its length, which is what our absolute value is. It's finding the length. So to go and find this, I will have the square root of 5 minus 3 quantity squared plus 2 minus a negative 4 quantity also squared. So we'll have the square root, 5 minus 3 is going to be 2 squared plus, don't forget to go in here and change, oops, that's really large. Change that to being positive. So then here I would end up with 6 squared. So this is going to be the square root of 4 plus 36, which is the square root of 40. Don't forget to simplify your radicals because you will have to do that. And so that's going to be 4 times 10. And that's as much as I can break that one up. So that would be 2 on the square root of 10. Okay. So that's using my point form. And so let's go and do it using our vector form. We should get the exact same answer. So with vector form, first we have to go find what my vector PQ is. So my vector is going to be my 5 minus 3, and then our 2 minus a negative 4. We'll include that value. That is a negative in there. So this ends up giving me the vector of 2, go and change that to addition, 6. And so now you can kind of see where the two formulas combine. And so changing over to the formula for my vector, to find the magnitude, that would be the square root of 2 squared plus 6 squared, which is the square root of 40, which we have already simplified down to 2 on the square root of 10. And so I think vector form cleans it up a little bit because you're not having to deal with all the stuff at the same time, but both end up working the exact same way. So let's go ahead and get some more terms for us. And so for vector addition and scalar multiplication, and so when you take two vectors, so using our common terms or names, u and v, each of them will have their own components. I'm going to use u1 and u2, using the ones to refer to the first component and the twos to refer to the second component. And that's more often the notation we use with vectors instead of using x's and y's. We'll name it first component, second component, because we could have three-dimensional components. And so we would use those when talking about like 3D motion. And so especially for those of you who are in physics or take physics next year or have to take it in college, especially if it's a calculus-based class, you'd have to talk about vectors a little bit more specifically. So the sum, another phrase, is also the resultant. It means when I want to go in and add two vectors together, I just add the two components. So I add the first two components together and I add the second two components together. We do not share them, okay? I can also end up multiplying a vector by a constant. So notice my U's in bold. It's hard to write in bold, so if instead you want to write U with the arrow over it to say, hey, look, this is my vector times a constant, you are welcome to. That tends to be more of my notation on paper because I can't make it look bold. And so I'm not expecting y'all to make it look bold. So when you're using the product, you just you distribute that constant inside to each component term, okay? So let's go ahead and talk about some more. Let's do some examples. So let's do some vector operations. So right now if I want to find 3u plus v, so I'm going to do scalar multiplication and I'm going to go ahead and find the sum or the resultant of adding them together. So first of all, if I go to find 3u, so that would be 3 times my 2, -1, which is my u vector. Please make sure to make your angled brackets look angled because they can blend in together really badly. And so that would be 3 times 2 and 3 times -1. So 3 times 2, I'm going to actually write that out beside it. That's going to be 6 and -3. I normally don't do the multiplication outside of the addition. I usually go ahead and write the addition and the multiplication all at once, but just because we're still learning this is why I'm separating it. And so you can show your work whichever way makes more sense, just make sure you're following algebra rules. So my 3u is actually 6 with my -3, and my v vector is my 5, 3. So if I go to add these two together, I'm going to get 6 plus 5 and -3 plus 3. 6 plus 5 is 11, -3 plus 3 is 0. And that is going to be my vector. So let's keep going. So unit vectors. So we're almost at the end of this. So our unit vectors are when their magnitude is equal to 1. Okay? And so if it's not the 0 vector, then we can make every vector into a unit vector. So I'm going to pull up our vector PQ from earlier, which was our components 2, 6, I believe. Okay. So, and we already found the magnitude of my vector PQ was 2 on the square root of 10. So if I wanted to turn PQ into a unit vector, okay, we would rename it. We tend to use U to refer to a unit vector. So what we'll do is I will take the vector PQ and I'll divide it by its magnitude. So that's just putting it directly into the formula. But all that means is when I put the component in there, so my 2 and my 6 divided by 2 on the square root of 10. Remember, multiplication is the exact same thing as division. And so my unit vector U will be the same thing as using my components 2 over 2 on the square root of 10 and 6 over 2 on the square root of 10. Okay, so let's go and simplify that. So I'm going to end up with my 2's canceling out there. I will have to rationalize that 10. 6 will become a 3 and 2 will go away. And so this one, when I rationalize it, so I'm going to multiply by the square root of 10 over square root of 10 on both of them because they both have the same radical, which makes it nice. I would end up with this I don't know if y'all can see that on the screen because of this watermark that's showing up. And so I'm gonna write it I wrote it really big. So I'm going to go ahead and we're going to add a screen in here to just give us some more space to finish this problem up. So we're going to move in on up because it's not letting me move it. So my vector u is equal to the square root of 10 over 10 and 3 square root of 10 over 10. Now if we went to go find u's magnitude, it would go ahead and give me the option to, we would end up finding that its magnitude is now equal to 1. And so all we did to do that was we divided its magnitude, its vector by its magnitude. So let's go and find this unit vector. Okay. So to do that, first we have to find the magnitude of my vector. So since this one is in vector format, it's going to be the square root of 2 squared plus negative 3 squared. And this gives me the square root of 4 plus 9, which is the square root of 13. So our unit vector would be taking my 2, negative 3, and dividing it by the square root of 13. So that's going to be the vector 2 over the square root of 13 and negative 3 over the square root of 13. If you have to rationalize when you're doing your online homework tonight, please read the fine blueprint. It is very specific about decimals or exactness, and read it to help you not be so frustrated with it, okay? So with it, I would have to go in and multiply both the top and bottom by square root of 13 over 13 if I have to rationalize. If you don't on the online homework, then you don't have to and you're good to go. So this would give me 2 on the square root of 13 over 13 and negative 3 on the square root of 13 over 13. That would be my vector. Okay, so there are two very special types of unit vectors that are our standard unit vectors. Okay, and so they're the vectors I and j, and they're called my standard unit vectors. Oh, sorry guys. And so they are my standard unit vectors, and we honestly use them to write out most unit vectors that we know. And so the v that we had on our last problem was the vector 2, negative 3. I can rewrite v to be j because j has that one where the first, I because it has that one where the first component is. That's going to be like the x part of my vector or my first component of my vector. So I can write this out as 2i. And then that would be minus 3. Well, the second component, j is the one that has the one in the second component. And so we'd have a 3j. So I can write any vector out this way. So let's go practice one or two of these, and then that'll be our lesson for today, and you can go look at the online homework. So with that, when I have let's look at the vector 3, 6. Okay, so if we're doing 3, 6, then I can rewrite this vector. So it's equivalent. It's just another notation to write it out. The ij notation is the one that you will see more often in like your physics classes. And so this would be 3i. I comes first in the alphabet, so it's going to be your first component. And then J comes second in the alphabet, so it's going to be your second component. And so if we go to try another one, so -7, 13, okay, it's equivalent to go in and say that this is -7, I comes first in the alphabet, plus 13J. Okay, I'm not going to ask you to go in and prove like our previous slide did. Okay, so our previous slide went through and showed you how you can rewrite any in terms of standard unit vectors. And so I'm not going to make you have to go through and show me all those pieces. Okay, but it did break it up for us as to how it worked. So that being said, your homework now is online. And it's going to be 6.1, day 1. It's going to be due tomorrow, which is 3/26 at 3 p.m. Okay, so let me know if you have any questions. I'm here to FaceTime, or we can set up a Zoom if you have more questions or concerns, and I'm here to help, guys. Miss y'all. Bye.